Hey there and welcome. Today, we're going to do something a little different. We're going on a journey, straight up, into something we're literally inside of every single second, but probably don't think about too much. The atmosphere. I mean, it's the air we breathe, our planet's invisible shield, the engine for all our weather. It's everything. So let's start climbing and take a look at this amazing system that makes our world possible.
So let's start with the most basic question you can ask. Seems pretty obvious, right? But think about it this way. You can go for weeks without food, you can last a few days without water. But without air, you've only got a few minutes, tops. That really puts its importance into perspective, doesn't it?
And we do it constantly. We eat 3 meals a day, maybe drink some water here and there, but breathing? It happens every few seconds, automatically without us even thinking about it. That simple, constant action just goes to show how deeply fundamental the atmosphere is to pretty much every living thing on Earth. Now get this, 99%. That's a huge number, right? Well, that's how much of the entire atmosphere's mass is crammed into just the first 32 kilometers above our heads. It stretches out way, way further than that, but almost everything that matters is in this incredibly thin, fragile layer right on top of us.
So here's our game plan for this little trip. First, we'll break down the air we're breathing right now. Then we'll look at some other key ingredients floating around. After that, we'll start our ascent, layer by layer, through the weather zone, past the ozone shield, and all the way up to the edge of space. All right, let's kick things off. Section 1. What is actually in this air that we depend on for every single breath? So, quick pop quiz. What's the air mostly made of? If you said oxygen, you're not alone, but it's actually nitrogen. A whopping 78% of the air is nitrogen. Oxygen, the stuff we actually need to live, that's only about 21%. And then you've got this tiny little 1% sliver left over. But trust me, what's hiding in that 1% is a total game changer for our planet.
Yeah, that tiny 1%, plus some other things that aren't even gases, plays a massive role in shaping our entire climate. See, it's way more than just a simple mix of gases up there.
For example, let's talk carbon dioxide. You can think of it like a one-way mirror for heat. It lets sunlight come straight through to warm the Earth, no problem. But when that heat tries to leave, CO2 blocks it, trapping it in. It's this greenhouse effect that keeps our planet warm enough for life. And we all know that as we've burned more fossil fuels, the amount of CO2 has gone up, which in turn has raised air temperatures.
Then there's water vapor. This one acts like a planetary blanket. It helps hold in heat, keeping Earth from having these wild temperature swings between scorching hot days and freezing cold nights. And its concentration is all over the place. It can be as high as 4% in the hot, humid tropics, but less than 1% in the freezing, dry air near the poles. And it's not just gases floating around up there. Our atmosphere is also full of these tiny, solid particles, stuff like sea salt, ash, pollen, even little bits of disintegrated meteors. Now, they might sound like just, dust, but they are so important. They're what scientists call hygroscopic nuclei, which, is a super fancy term for something simple. They're the seeds for clouds. Without these little specks for water vapor to grab onto, you wouldn't get clouds at all. Isn't that wild?
Okay, so we've got our ingredients list. Now it's time to actually start our journey up through the atmosphere's layers. First up, the troposphere. This layer is basically our home. It's where we live. The troposphere goes up to about 13 kilometers on average, but it's actually thicker over the equator, where all that warm air pushes it up. And pretty much everything we've talked about, the dust, the water vapor, and all of our weather, it's all happening right here. And as any mountain climber knows, the higher you go, the colder it gets. The temperature drops about 1 degree Celsius for every 165 meters you climb. And honestly, it is impossible to overstate this point. This layer right here is the whole show. Every single thing that life on Earth needs, from the air we breathe to the rain that grows our food, it all happens in the troposphere. For all biological activity, this is without a doubt the most important layer.
So at the very top of this layer, there's a boundary called the tropopause. Think of it as the ceiling of our world. And if you're over the equator, the temperature at that ceiling plunges to a truly staggering minus 80 degrees Celsius. Incredibly cold.
Okay, time to punch through that cold ceiling and head up into the next layer. Things get very, very different up here. We're about to meet our planet's unsung hero. Welcome to the stratosphere. This is a huge layer that sits way above all the weather, and it extends all the way up to 50 kilometers high. And here's something interesting. Unlike the troposphere we just left, in this layer, it actually gets warmer as you go up. And the reason why is because of its most famous resident. And that resident is, of course, the ozone layer. This is Earth's built-in sunscreen, and it is absolutely crucial. This layer of ozone gas soaks up the most dangerous kind of ultraviolet or UV radiation from the sun. And it's that very process of absorbing energy that actually heats up the stratosphere. So it's a shield that literally warms itself up while it's protecting us. Without it, life on land just couldn't exist. We've passed our protective shield, so let's keep going. We're pushing into the high frontier now, heading for the outer limits of our atmosphere where the rules start to get a little strange. All right, up we go again. And this is where things get, well, kind of weird. You're about to see this wild temperature roller coaster. As we climb through the mesosphere, heading for that 80-kilometer mark, it gets colder and colder again because there's no ozone to heat it. But then, bam, you hit the thermosphere and the temperature just flips. It starts skyrocketing the higher you go because the super thin air is just soaking up all this intense energy from the sun. And when we say the mesosphere gets cold, we mean it. At the very top of that layer, about 80 kilometers up, the temperature can hit minus 100 degrees Celsius. It is by far the coldest part of Earth's atmosphere. Now, tucked inside that super hot thermosphere is another special region called the ionosphere. It gets its name because it's full of electrically charged particles called ions. And this is really cool. This layer is what makes long-distance radio possible because it literally bounces radio waves from Earth back down to the ground. And at last, we've reached the top of the ladder, the exosphere. This is it, the final layer. The air here is so incredibly thin that molecules are just few and far between. This is the last frontier, where our atmosphere just sort of gently fades away into the complete vacuum of outer space. So, we've made the trip from the ground beneath our feet to the very edge of space. We've seen how every layer, every gas, every little particle has a specific job to do. It's an incredibly complex, finely tuned system, which, of course, leaves us with one last big question to think about. If this whole thing is so perfectly balanced, what happens to the entire system when we decide to alter just one small part of it?